Hello and welcome to the Java Essentials for Hadoop. Here we'll be covering the concepts of Java that you'll be requiring to understand and work with Hadoop better. So the basic agenda for this webinar will be what is Java, the features of Java, JVM, JRE, which are a part of Java, now how Java works, the data types and operators associated with Java, static versus non-static variables, statements and blocks, the flow of control in Java, basic constructs that are dealing with Java, and arrays, and at last we'll be dealing with the Java classes and the methods. Now starting with what exactly Java is. So Java is a programming language which is first released by Sun Microsystems in November 1995. At that time, it came under the secret project called Project Green, and it is headed by Mr. James Gosling. Now, Java, as stated by Sun Microsystems, Java runs on over 3 billion devices. Java can be used to create desktop applications, web applications, as well as mobile applications. Now, Java can be used to create complete applications that can run on a single computer or a distributed set of computers and servers which are connected through a network. Now, the basic and the most important features of Java. First, we'll start with Java is simple. This I can say because the syntax that we use in Java is very similar to C and C++. The second one is object-oriented. Java is an object-oriented programming language, and we are dealing with the reference types and the objects here. Now the multi-threaded. Since multi-threading is a fundamental concept of a computer program, and this idea of handling more than one task at a time, which are separately running pieces, and these are called the threads. This general concept is called multi-threading. Now the dynamic. Java supports dynamic language support. Java has the capability to run not only the Java applications, but also it have the implementation of many other languages. There is dynamic memory allocation for every variable, may it be a reference type or a primitive type. Now, the architecture neutral. Being architecture neutral is the best part that Java provides. It is the first language which came up with the architecture neutral thing. Java revolutionized programming language and the world of internet using this term. Now explaining this term, architecture neutral means a developer can develop an application, compile it at a computer, and brings out an intermediate form of it, which is called as bytecode. Now this bytecode can be distributed to n number of computers and n number of developers, and this can be run at any time, anywhere, without any modification, and the result will be the same in every device. Now coming to the portable part. Since Java is architecture neutral, the code that we write there, we compile it and we can port it to any computer, giving the same result. Next is the robust. Robust means reliable. Java puts a lot of effort on early checking for possible errors. And it has strong memory allocation and automatic garbage collection mechanism. The last part is security. Java platform provides a number of features which are designed to improve security of Java applications, which may include enforcing runtime constraints, or I can say there are many suites of security APIs that deal with the security. Plus, the main point, the which C and C++ are providing is the explicit pointers. These explicit pointers can be used to point to some part of memory and cause security hazards. So Java has totally removed the explicit pointer part and the security part is enhanced. Now coming to the JVM, the full form of JVM is Java Virtual Machine. Now here you can see there is an image which have a simple class called Hello World app, and a very simple task is done by this Hello World app. It prints to the console the string Hello World. Now this Java class is compiled to an intermediate form which can be handled and interpreted by the JVMs of different machines. And the JVM of different machines print the same thing, which is the Hello World, and there is no modification required in the code. So basically what JVM is doing is providing the architecture neutral part. As it is written, it makes Java platform independent, and it also handles the memory management. Now JRE. So JRE stands for Java Runtime Environment. Just like we people are living on Earth, we need an environment to live in. In the same way, Java programs need an environment called JRE. So the JRE is comprised of the JVM, Java Virtual Machine, and some APIs, application programming interfaces. Now I would like to tell you how Java works. Let's look at this diagram. Here is a Java class, which is Java file, which is named as myprogram.java. Now the compiler compiles it into an intermediate form, which is myprogram.class here. It could be a jar file also, but since this is a Java class, it is .class. Okay. The JVM here interprets this class and converts it to the 0-1 form which the machine understands. Now the JVM along with its interpreter uses a just-in-time compiler, and this just-in-time compiler is used for the performance boost. Now there are different data types that are associated with Java. Some of them are primitives, which you have already used in C, C++ if you have gone through C, C++ in your college or school time. So I'll just quickly brief you through it. This is a boolean which contains true and false value, a char which can have Unicode character set, a byte, short, int and long. All of them are of integer types, although the ranges are different, byte is the shortest and long being the largest of them all. And there are some floating point integral values also, like float and double. So these are the primitive types. Java also supports non-primitive types. One of the most important non-primitive type is the string. Now here I would like to tell you that in C, C++, there is nothing like strings. There are only character arrays. But in Java, there are character arrays, plus there are strings. The strings are the streams of characters and not the character of arrays. Now here come the operators. There are different operators that are associated with Java, namely the assignment operator, the arithmetic operator, relational operators, logical operators, and unary operators. Now coming to the variable parts, the static variables and non-static variables. Non-static variables are also called as instance variables. The basic difference between them are static variables are shared across all the objects of a class, but the non-static variables are never shared. Non-static variables are exclusive for each object. Each object has a different instance variable for itself. The static variables have only one copy, but the non-static variables, as I've already told you, are different for every object. Also, the static variables cannot be declared within a method, since they are associated with a class and not a method. But a non-static variable can be declared within a method. These are the basic differences between static and non-static variables. Now, the statement and the blocks. Here you can see this, the highlighted part. This is a statement. And why this is a statement? Because it is syntactically correct and it is terminated with a semicolon. Here we have used a data type called string and a reference name called name, which is assigned a value using the assignment operator, and we have assigned the value Stanley to this name. And a string is always quoted under these double quotes. Now coming to the blocks. Block is the compound statement. A block may consist of one or more statements in it. Java makes use of these blocks very extensively, and these are helpful in making the scope and lifetime of a variable. And also the blocks may contain another blocks, and they are called as nested blocks. Now coming to the flow of control. In Java programming, the flow of control is from top to bottom and left to the right. Now, this flow, the top to the bottom flow, can be break by the control flow statements, such as we can employ decision making, looping, and branching, so that the program is able to conditionally execute particular blocks of code. And this may be required in some kind of logic that the developer may think of. So many Java statements that come under flow control statements are if else, switch, and the loops are also there for while and do while. Now these are the basic Java constructs I have already told you: if else, switch, for loop, while loop, and do while loop. Now this is the syntax for an if else ladder. Here is the condition. This is the block if it is true, and if it is the condition is false, this is the block to be executed. Now this is the syntax for switch statements. So depending on the expression, if this case meets the expression, this block is executed. If this meets the expression, this block is executed, and nothing meets the expression, this block will be executed. Now coming to the for loop. For loop is a very tidy loop. Everything is done within these parentheses. Initialization, the condition which is checked is present here. The increment or decrement, these are also present here. So these statements are executed until this condition is met. The example we'll be looking at when we'll be doing the hands-on on NetBeans. Now the while loop, the syntax of this is, there is a condition, if this is returning true, this block of code will be executed. If this returns false, nothing will be executed. Coming to the do while loop, just a small difference between a while loop and a do while loop. if this condition is false in a do while loop, at least once these statements will be executed. But if the statement is false in a while loop, it won't be executed for even once. Now arrays, but before covering arrays, let me give you some hands-on on these constructs. So let's first start with if. Okay, so this is a class called if demo, and keep in mind that the name of class starts with a capital letter and it uses a camel case. Now this is the main entry point, the main method. Now we have initialized two variables, namely I and j, with a value 5 and 10 respectively. Now this is the if-else part, which is the important part here. We have used conditional operators over here. This is the equal equals, which checks the equality. If I is equal to 5, here I is containing 5, so this statement will return true. J here, it is checking for 10. If it is equal to 10, yes, it is indeed equal to 10. So this returns true, this returns true, and in between there is a logical AND operator. What logical AND operator says is, if both the statements are true, then only it will return true. So this will return true. That means this block of statement will be executed. Let's see if this really happens. Shift F6, and here you can see this block is executed. Result is correct. And suppose we change it. We make it 9. Then we are doing Shift F6. Now it is saying the result is incorrect. And indeed it is right, because 9 is not equal to 10. It can never be, right? Okay, now let's come to the switch demo. The name of the class is switch demo, and here the main, and we have declared a string named Vic. It is a random name, Vic, and we are switching on this string only. Now there are different cases. The case 1 is Vic, case 2 Zohed, then Joe, then Max, then Fred. Okay, so if this case matches, this code will be executed. If this case matches, this code will be executed, and likewise. So here, as you can see, this is the case which is matching. So the output should be, it is Vic. And here you can see the scope of switch is still here. So as soon as switch is completed, this statement should be executed. So let's see if this really happens. Shift F6, and right, absolutely, it is Vic here and outside switch. This is what we needed. We wanted this output, we got this output. Now let's suppose we change it. We change it to Joe. So the case that is matching here is this one. Okay, so let's Shift F6 and see. Yeah, it is right, it is Joe, and we have this only here, and then it is going back to the outside switch. Now if we do a random ABC, since none of the case have this ABC, the default case will be executed. Let's see, Shift F6, and indeed it is right, it is no one, and it is coming out of the switch. So this break statement, this is the one which is helping us break out of the switch statement. When the Vic was right, this statement was executed, then this statement came under, and what it did, it break the flow from the switch to the next statement after the switch. Okay, now let's jump to the looping part, and let's start with the for loop, the very tidy loop, the for loop. So the initialization part is present over here. I is equal to 1. This is initialization, I have initialized it. The condition that I am iterating through is I is less than equal to 10. So till this condition is true, the loop will iterate. and I is I++. What I have done is, this means I equal to I+1. I am incrementing the value of I. And simple, I am outputting this value, the value of I, to the console. So let's see what the result will be. Shift F6, and here you can see it is the natural numbers from 1 to 10. Since it is containing 1, we have initialized it from 1. It checks for the condition I is less than equal to 10. The condition is true. It prints I, then goes inside the loop. I becomes 2 over after the incrementation. It checks with the condition 2 is less than equal to 10. Then again prints. So this happens till 10. So at the time of 10, it will check 10 is less than equal to 10 and it will print. Then it will increment to 11 and the loop will break after the condition is checked and it won't be executed. Let's come to the while loop. Now I have initialized a value I and given it a value 0. Now in the while loop I have given a condition, iterate it till I is less than 10. So I am outputting the value of I and incrementing the value of I. So it will become 0 here, it will check it is 0 here, it will check for the condition, it will return true, it is 0 is less than 10, it will print, it will increment, and this will happen and happen and happen till I becomes 10. As soon as I becomes 10, the condition becomes false. This statement won't work. This block won't work. It will go out. And subsequently, the program will terminate. Let's see, Shift F6, and here you can see the output is from 0 to 9. Okay, so let's jump to the do while loop, and here keep a close watch on this one because this is a bit different from the while loop. It will execute at least once even the condition is false. Here I have initialized I with a value 1 and it is doing the same, outputting it to the console, then incrementing the value of I, and after that checking the condition. So let's Shift F6 and see the result. Brilliant, 1 till 10. Absolutely right. But what if we change it? We'll change the condition. Let's make it while I is greater than 10. Since we know I is 1, it can never be greater than 10. 1 is never greater than 10, right? So let's say Shift F6, and here you can see we got 1 even though the condition is false, since it is 1. And also it has incremented. I can show you it has incremented. Let's copy this, let's paste it over here, and it is showing the value of I. Shift F6, and here you can see it is incremented because of this statement, right? So we are good here. Okay, so these are the hands-on that I wanted to show you so that you get the clear concept of what we are doing. Now let's come back to the array part. Array are the most important and most widely used thing in programming languages. It is basically used to store a list of similar elements, homogeneous elements. Now in Java, an array has a fixed name, fixed type, and a fixed length. And all of these must be declared when the array is created. And the size of array cannot be changed during the execution of the code. These are the points to be remembered. Now this is a very short example. I will give you a hands-on on NetBeans for this. Let's jump to the simple array demo. This is a very simple class which is named as simple array demo. This is the main method, the main entry point, and here you can see. Let me just make it like this. Yeah, let me explain it to you here. Here we have an array and we are defining, this is a bit different in C and C++. We have to specify what size of array we need when we are sorry for that. Yeah, we have to give the size of the array when we are giving a reference to it. So here the data type, and this is upon you. You have to give these square brackets after the data type, or you can give these square brackets after this numbers also. That depends on you. But the conventional way is to provide the brackets after the data type. Now this reference, the numbers reference, is given a dynamic allocation of these arrays by using the new operator. So new, then what type of data it will contain? It will contain int, and what size? It will be of size 5. So size 5 means 5 elements, and the indexing will start from 0. So the index that this array will contain will be 0, 1, 2, 3 and 4, and not 5. Okay, 5 will be out of the bounds. If an array has 5 index, it will contain 6 elements, right? Now this is one way of filling up an array. I have used numbers index 0, put 10, and number index 1, put 20, and likewise and till numbers index 4. So I have filled the array, whole of the array. Now what this loop does is it prints the array, the whole of the array, and here it is putting a single line. And in this loop, what I am doing, I'm changing these values, the values that the array is containing, and replacing it with 1. So let's see what the result will be. Shift F6, and here you can see this array contains 10, 20, 30, 40, 50, and exactly what we are getting from the first loop, this loop, right? And in the second loop, which is this loop, we are getting 1 because we have assigned overwritten the value of the array with value 1. And the very important thing that I need to mention over here, here you can see the condition. I am using numbers.length. Length is a property over here. Arrays have this property which specifies what is the length of the array, and this is a very helpful property when you are dealing with arrays. Okay, so this is the basic example of an array, and now let's jump to what we have, Java classes. Okay, so this is the basic thing. Every program you are writing, you will write it in a class. When you are using Java, you have to write every program within a class. It is the basic way of encapsulating. Now, a class can be defined as a template. It works as a template. So it will be describing different types of behaviors or states that its object will support. Now, the objects. Now, you may take an example, a very simple example. You can take a dog. So the states it can have are the colors, what color the dog is of, his or her name, what breed it is, as well as a dog will have behavior. He can wag, he can bark, he can eat. Okay, and different dogs have different habits of eating, barking and wagging. So behaviors will be different for different, right? So in the same way, in Java, the objects have states and behaviors, just like the real world. And an object is an instance of a class. Now this is an example of a class. It's a very short example, very precise example. So this is a public class. Public means It is the modifier which says that you are available everywhere. Any class can call you from anywhere. And we'll be dealing with these modifiers in the later part of the webinar, most probably the second webinar that will be seeing you on. Okay, so the class name is car and the scope is this, and some instances are there, instance variables are there, plus there is a main method. It may or may not contain a class, may or may not contain a main class, main method. That depends on you. Okay, so this is the basic structure, just for your understanding. Nothing really important, just you have to understand it. Okay, now comes the methods. This is a very important part. Method, if you have worked on C, C++ at any point of time, you will be familiar with methods. They were called functions and procedures in that. And in Java, there is only methods. And that depends on you if you want to return the value or you don't want to return a value. So a basic definition of a method is, it is a named sequence of code that can be invoked from other Java code. A method can have multiple parameters or no parameter. That depends on the coder, what kind of code he is writing. And it may perform some computations and optionally can return a value. That depends on him or her. There is a small example, but we'll see a hands-on on methods. So the 5 basic components of a method are the modifier, that is public, private, or default. Okay, so this modifiers will be covered, as I've told you, in the later part of the webinars. And the return type, like what the method will be returning. If it doesn't return anything, you have to use void. Void specifies that it doesn't return anything. A method returns nothing. If it is returning an integer value, you specify here int. If it is returning double, you specify here double. Now the method name. It is the identifier for a method. The method name. You have to call the method using the method name. Now there are the parameters list here, and it can be of any number of parameters. It can contain any number of parameters, 0 till your memory doesn't overflow. And the method body, this part, the method body will contain the statements to be executed. Now modifiers, but before modifiers, I want to show you the method demo. This is very important. Understanding methods. So first see this class, the use method class. Use method class, sorry, just a second. So this use method class contains a method called add. The name of this method is add, and it is returning an integer value, and the access specifier is public, so it can be called from anywhere. Okay, and there are 2 parameters that are passed to it. So these parameters will work as a local variable inside this add method. Now, since it is returning an integer value, this expression must return an int. Okay, and the return keyword is used to return a value. So here I am doing is number 1 plus number 2, so I am adding here and I'm returning it. So now let's come to the method demo class. There is a main method entry point, we make an object of use method over here using this reference meth. This made the object and it is assigned to a reference type called meth. And using this object reference, I am calling add method, which is this method, and the actual parameters are 4 and 2, which are passed to number 1 and number 2. And the value which is returned, that is the addition of this, is assigned to another int named result. Now this result is printed on the console. Now let's see if it really adds these 4 and 2 and gives us the result 6. Let's see, shifts F6, and yes, this is giving 6. If we change this, let me change it to 78. Shift F6, it will give 80. Well, good. We are good here, right? Now the last thing are the modifiers. There are 4 different types of modifiers in Java. First is public. If we are using public as a modifier, anything which is specified as public can be accessed from anywhere, right? And the second is protected. Protected, if we are using, that can be accessed in the same package or any derived class. Now the Java packages we'll cover in the next webinar. These are synonymous to the folders in Windows. The third one is the default modifier. For default, we don't need to write anything. If no modifier is specified, that means it is of default scope. So it can be accessed within the same package, that is the same folder. Private gives the security, because anything which is private can be accessed within the class only, and no one else outside the class can dare to call anything which is private. Okay, right, we are good. So this was the last thing that I wanted to cover in this webinar. So I think you are well equipped with a bit of knowledge, and I would like you to put up some questions if there are any. Are there any? No? Okay, so we are good, and I would say you need to practice on this. I will be giving you some assignment questions, and be good students and try to solve them. Thank you.